I don't know if you heard about this little virus thing. Everybody seems to be blaming everything on it. We didn't get to travel, whatever. Our next speaker, I'm sure he blames it that he hasn't been doing a presentation in front of a lot of people, or even few people, for a long time, that he, during the training day, actually managed to lose his voice. So we're going to have a very quiet presentation from James up here. Me personally, this is going to be the most boring presentation of the thing, because it talks about if you have a bug in your application, it crashes, and I mean, so give a hand to James.
Hi, everyone. It's going to be a lot of this. Sorry, I'll try and make it even. I'm here. I work for QtDev, but for my many crimes, I maintain an open source project in my spare time, which is called Flight Gear. It's a flight simulator. You can fly airplanes. Apart from that, I work for QtDev doing C++ development, and I've been doing open source work for different open source projects for 20 plus years. That's kind of how I ended up at QtDev, but it's also how I ended up doing work on Flight Gear. That's meant UI work, OpenGL work, unfortunately build and release engineering, and unfortunately it's meant often being the first point of contact for end user problems and end user support, which is what led me down the path we're going to talk about here, is being the guy on the mailing list being like, I better reply to that person who's got this problem. Because a lot of developers are really good at ignoring the mailing list or the GitHub, bug reporter, because it's just a minefield of terrible reports and badness. But I had enough kind of stupidity or conscience to actually go and answer the email and try and figure out why this person is unhappy or why it's crashing for them. I'm not saying that all open source projects do this badly. Like Niels Lohmann was talking about this, obviously does a really good job, but clearly a lot of open source projects, the bug tracker is just a wasteland of unanswered questions and problems. I'm specifically going to talk about Flight Gear. That doesn't really matter, except that it's a big legacy C++ code base. It's 25 years old now. It's got lots of contributors, many of whom have gone, like they've moved on. It runs on Windows and Mac and Linux, and used to run on Solaris and HPX and things. It's data-driven, so it loads lots of kind of XML content and script content, that kind of stuff. And some of that comes from users. So it's a bit like a game. It loads kind of add-ons or plugins, whatever you want to call them, full of stuff made by people who aren't always super technical. They're kind of dangerous enough technical. They can copy and paste, but they're not like coders. It downloads content at runtime, which is like another whole Pandora's box of ways stuff can go wrong. It's a 3D application. It uses OpenGL, which is yet another whole set of ways things can go wrong. And it's gradually acquired threading with no design, architecture, planning, or intelligence. Like, oh, this is slow, let's add some threads. And this combination of things is maybe the worst you could do. I mean, maybe there's worse ways you could do something here, but in terms of a complex C++ code base of variable quality with things likely to cause problems, this is a pretty good place to start. By the way, who's actually heard of Flight Gear before I mentioned it? Show of hands. Who's used it? Okay. Did it crash? Hooray! Okay, good. You're lucky. You're one of the lucky ones. And I can sort of show that statistically now, which is cool. So the bad news is this is actually a group therapy session from me. Jesper's now locked the door, and I'm going to sit here and whine about the last X years of my life fixing shitty bugs and other code I ended up maintaining. Sorry, this is just me venting now. But hopefully you might learn something interesting along the way. Welcome to my therapy session. You all paid to attend. It's cheaper than me going to therapy, for me. So we have the 5 stages of a user-reported failure, which I think you all know. You can say them along with me. That can't happen. What's next? How does that happen? I didn't swear for Jesper. Bargaining, of course. If you reinstall the drivers, or if you don't load that airplane, or if you run it on something else, does it still happen? Then we have depression, obviously, where I just throw it all in, don't look at the emails for a week, start drinking more. And then finally you have the, okay, I figured it out. I hate computers, fix is pushed. Yeah, and this is repeated. And it's not the most pleasant mental cycle to go through. Familiarity for this for anyone? Does anyone sort of out there relate? Okay, good. It's not just me. If you want to come on stage, we can do like a group session, like really like going around like, oh yeah, this happened and it was awful and I wanted to strangle this user. Yeah, we can do that. So the direct motivation for all of this is that I had some vocal users saying, oh, the software's getting more crashy. And I was the guy doing things like fixing the threading and refactoring some crappy memory ownership and just improving the code base. And to some end users, this just looked like some C++ guy messing around in the code. And then they'd say, well, since you did all this messing around, now it crashes more for me. And I'd be like, where? How? What were you doing? They'd be like, it just crashes more. Like, okay, that's not actionable. I don't think I crashed it. I made it more crashy, but sure. And getting good feedback from users is very, very difficult. So one thing I realized from Niels Lohmann's talk is that if you make a library, your users are developers who, for their many, many crimes, which you're all aware of, do give pretty good feedback about code. Whereas end users, and the Flightgear user base includes kids and retired guys and everything in between, and people who can't afford to buy Microsoft Flight Simulator and have like 20-year-old laptops, getting feedback from them is really, really difficult. They don't even know what a log file is. They copy and paste things from wiki pages and don't understand that white space is important in command lines and all of this stuff. But very occasionally, the Linux users would send me a core dump or a backtrace, and I could typically fix the problem. And weirdly, on macOS, which you'd not normally think of as being the kind of developer-friendly platform, Crash Reporter would pop up this thing with all this technical nonsense in it about symbols and frames, but it has a copy to clipboard button. And people could successfully copy that report and paste it in an email. And then usually you could work out what the crash was, or the issue, because you just had so much more information to work with, and the user didn't have to be very clever to get that information to me. So obviously my brain went, cool, let's integrate a crash reporting library, and life will be better. And by the way, the Linux situation is complex because some of the distros now try and also help you at this and do some automatic collection, but it never seems to quite work the way I would expect it to anyway. I think it might work well if you're a shipped application on, say, Ubuntu, and it crashes. I think they put it into their tracker automatically, but Flightgear doesn't work that way, so that didn't help me. So I went, this is actually maybe even 6 or 7 years ago, and found myself a crash reporting library, which is basically something you deploy with your application. It typically installs a signal handler or equivalent on Windows. You build your application in release mode with symbols. There's a CMake caveat there, which is it turns out that if you switch CMake from release configuration to release with debug info configuration, it changes how your program is built. Anyone aware of this one? So CMake, the default compile flags for release is 03. CMake default flags for rel with debinfo is 02. So we lost about 20% FPS because we went down an optimization level without realizing. You have to basically go and make sure you reset your flags back to what you actually want when you switch to rel with debinfo in CMake. That really was surprising, but we didn't notice for a few months and realized something had got slower. But yeah, you build with debug symbols. You do this extraction archiving step where you, having built the binary, take the symbols out into, well, they're already out if it's Windows because they're PDBs, but on Mac and Linux, there's this extracting the symbols into its own DLL on Linux or DSIM on Mac. And so then you strip the code down, you package it, you sign it, you deploy it, whatever, and you automate all of this on your CI or Jenkins because it's all a bunch of manual post-build steps, which you can make nice. So I did all that, and this was a while ago, and I thought, great, I've got a crash reporter library in, I've done the symbol thing work, and what I achieved was nothing. I picked this library called Crash RPT, which is simple, it's open source, it's Windows only, because I was like, well, Mac's already got a solution, Well, Linux kind of is its own thing because of core dump files. I just deal with Windows, and that's fine. And crash report's like 1 megabyte of code, or even less. And it basically does a HTTP post, or maybe it's a put, to an endpoint you supply. I put in my DreamHost server that's got lots of storage. And essentially, there's a directory there that fills up with these little zip files which contain the mini dump file, which is essentially like a core file, and the log, and whatever. And then you have to go, if you want to use that, to go and open up the zip and work out which files it was, and then correlate that to the PDB of the build, and you could work out a crash trace. And in practice, I never did this, because I've got a directory on a web server filling up with tens or hundreds of zips per day, with no information apart from the file name is all just a long code of digits, dot zip, and inside there's some information. But then to go and make that usable just escapes me. For me on my own, that wasn't an actionable set of things to fix the crash. So then a few years pass, and the directory periodically fills up, and I empty it because I just can't do anything with the data. And then through KDAB, we worked with some different tools in this area, so I made a second attempt, which was basically the start of lockdown. This was kind of my lockdown kind of project on flight gear. So I found a better system that has things that make this useful. And this is not meant to be a plug for the system I ended up using. It's more about the minimum features you need to make this actually work. You need a back-end service, almost certainly web-based, that does the aggregation. You need it to do the symbolication for you based on the build ID and it having all the different builds and knowing their symbols. And that correlation between builds, release, or whatever. You need it to ideally know the symbols from your vendors, because it turns out most of your symbols aren't yours. They come from NVIDIA and Microsoft and Intel and AMD. That's probably the big one. Oh, and Qt, of course. Yeah, and the other libraries you're using. But you need that whole stack symbolication, because almost certainly your frame is full of symbols that aren't yours. And you really, really wanted to do some kind of grouping based on metadata. So just it's a crash is nice, but actually there's lots of information when you're running that can make this much more statistically useful, because it turns out when you start looking at these things, you've got so many, if you can't make some statistical observations, it's very hard to move them forward. I mean, if you only get one crash, or none, like Jesper, great. But when you've got 10,000, you're going to need to have some way to analyze them. So the big thing that really changed this is crash context. And that's what the richer libraries are bringing now, is not just the crash trace, but what the user was doing. And this very rapidly starts to head into telemetry and analytics. It's really just a sliding scale where you've just got a core dump at one end and full-on web-style analytics at the other, and it's just how far along that you go. So the context is, what was the user doing, what configuration is set, and what weird things have happened already. And in practice, that means recording something like, each time you fire a Q action, say which action it was. Each time you trigger a button, I mean, not every single signal and slot in the Qt application, but the ones that say load screen or do print or start flying, those kind of key points in your program, or opening up a dialog or closing a dialog, they are the key points that give you the flow through the program. And then the configuration is, am I on Mac? Am I on Windows? What's the screen size? Is the user running portrait or landscape? Do they have an Intel or AMD graphics card? All that kind of stuff. All that configuration is super valuable. For flight gear, it's where were they flying? What plane were they flying? Were they using the real world weather, or were they using winter or snow or a thunderstorm? How big is their screen? Do they have lightning enabled on the visual display? All those kind of settings. And the anomalous things is basically your Q warnings and maybe your Q infos from your log stream. It's like, did a file fail to open? Did you run out of memory? All that kind of stuff you'd normally just send to standard out or Q warning and forget about. They're a really good indication, because normally when you crash, something weird happened before. I mean, maybe, not all the time. But all that stuff, that context, is super valuable. And collecting that and having some, say, analysis over it is totally transformative. So practically, the system I'm using for flight gear is Sentry. That's Sentry.io. Say it's not a plug for them. We have used it at KDAB for some customers, but there's also a couple of rivals. There's AppVeyor, and there's another one I think called Crash.something. They all basically do the same thing. When I've talked to people about this, some of them obviously have different features, but they're all kind of in this area now. So this is about how you use the tools, not one particular tool. Sentry is nice because it has backends for different languages, including C++, which I needed. The infrastructure here is such a big deal that actually they use a different library for the actual bit of getting the crash trace. So they use either CrashPad or BreakPad, which are from Google, as their actual literal I grab a crash. But all the machinery around the back end and the context and that all comes from Sentry itself. The actual work of just getting you that crash trace is kind of a little 1 megabyte library, but it's all the infrastructure, the ecosystem that's usable. And again, all of the different option vendors here give you the ecosystem. So Sentry gives you like a command line tool you run on your CI that will do these, extract the symbols. You'll upload it to their server. It'll do a hash of the PDB against the XC so it can correlate them when they come in later. Nicely, it offers self-hosting and hosted solutions. And very nicely, for an open source project, they give you it for free. So again, it was a nice one for me, just like, okay, it's free. I get 1 million crashes per month, and even Flight Gear doesn't crash 1 million times per month. Although we gave it a good shot, as we'll see. And nicely, actually, they are good open source people. So I was using their CMake integration and found an issue and filed a bug, and they fixed it, and they talked to me. So they seem like good human beings, but again, not sponsored, just they were good to work with, and they were free for open source. So again, that's kind of the machinery. Here's what I thought I was fixing. I mean, it's a C++ application. I thought I was going to have lots of code that looks like, get a pointer from something, forget to check it, use it, crash. Okay, I did check that the airport A there is valid, but I didn't check that some member is valid because it wasn't initialized, because not all airports have control towers, for example. So there'd be lots of those kind of dumb, newbie C and C++ pointer errors and not checking return codes, those kind of easy things that crash. And of course, these kind of crashes, when someone says, I open up this dialog and I click this button and it crashes, you can often find those with a code read, because you kind of got some kind of user-level description of where they were in the code. You go to that file, you read through and you be like, oh, there probably should be a null check on that pointer. You add it and you discover it, you fix the crash. If you do get an actual crash trace, these are usually like a 2-minute fix, right? So this is why I thought I was going to be having this big collection of, and I'll go through, fix that one. They'll all be quite simple. Okay. That's not the reality of crashes from users, as I see it, certainly in Flight Gear. Now, it might be that because we've already fixed all the simple ones already, there's probably a factor there. But I think it's also just the time-wise, even if there are a lot of these, they're not the ones that occupy you. As far as I can tell, and this is my list, the reason your programs crash a lot is because computers are slow, your users are impatient, or more likely, the UI is bad. There's no such thing as an impatient user, they're just a UI that didn't tell them to wait longer, although, kind of. Their hardware is archaic and weird and doesn't do things and does do things. File systems, especially on Windows, are totally weird. Things like your home directory on Windows being on OneDrive, and therefore having really weird paths that don't do the right thing, and you try and write to that path, it turns out it fails. And yep, OneDrive is partly my bane. And it turns out malloc does actually fail. Who knew? I mean, why would you? Malloc never fails. Come on. Don't check the result with malloc. No. Turns out it does actually fail sometimes. I was surprised as you. So I'm going to go through some of these. I could go on more or less forever. What I was doing in lockdown was basically every couple of days just taking the top crash that made no sense at all of one of these, trying to understand it. And I basically kind of read it and be like, well, that can't happen. Because you still have the same cycle, just now you've got real information about it, like, how did it crash that way? And often it's iterative. You'd get some crashes coming and be like, well, there's clearly a problem in this area because there's 50 people having the same crash. Oh, that's one of the things the aggregation can do is say, these back traces are similar, therefore I'm going to combine them together. That's a really powerful feature, again, just to go from an unsorted sea of separate reports into clustering of these look similar enough that it's the same crash. That's really valuable. So yeah, I'd pick one of an evening, sit there, with my beer and lock down and be like, okay, I'm going to figure this one out. And most of the time I'd fail. It would take 3 or 4 or even 30 goes around of like how is it crashing there? So I picked out some fun ones for you, but mostly it's just that slog of trying to get your head into the space of what the program was going through to crash in that way. And yeah, it's always a thing obviously you didn't consider, but there's just so many options of it. It's really depressing and amazing at the same time. So we'll start with the first one, which is kind of one of those, like, this is actually from Qt, so it's quite a good one. So we have a database in Flight Gear. We build it on the first run. It's turning like half a gigabyte of ASCII into like 100 megabytes of a QSQLite database for optimization. It takes between 1 and 5 minutes, depending on if your computer is super fast with an SSD or old and slow with a spinning iron. And we have to do it first. So I use actually QProgress dialog, and it just says, this will take a few minutes, please wait, da 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 da. And then obviously to keep Qt happy, I do the actual rebuild of the DB in a thread. So there's a thread object I call start. I make my QProgress dialog, and I've got an update callback that basically says, OK, check if building the thread's done, and if we're done, close the dialog. And obviously then updates the progress, so the thread basically says what percent it's done as it goes through. Fine. And we call exec, because it's a QProgress dialog, and then we carry on with our startup, knowing the database is built. And turns out we had a whole bunch of weird errors where the database is not built, and it gets to like, this somewhere down here, and it turns out, and this took me a few times of adding log information in, and again, context saying, OK, we started building the database, we're halfway done, we're finished building the database, we're closing the dialog, and what eventually came out is that we were closing the dialog before the database was done building. So if you know QProgress dialog, what have I screwed up here? QProgress dialog is pretty simple, so yeah. It does have a little cross, but I turned that off. I'd hidden the cancel button, because you can't cancel this, which again, arguably is bad UI, but we can't run the program that they did at the database, so I hid the cancel button. People are sitting there waiting, they're getting very frustrated, they're not very technical, they start hitting every key on their keyboard, and it turns out, even if you get rid of the close button, you can still hit Alt F4 on Windows and close the dialog. You have to go and set a special flag on QProgress dialog to basically say, ignore key events, otherwise it'll close. And then exec comes out, and you're dead. That was annoying. Next one is very similar. So Flight Gear doesn't use Qt for its main UI, uses it for part of the UI. I'm a macOS user, so I hated the horrible, weird menu bar we had. So I made a native menu bar just using Cocoa, could have used Qt, for the menu bar. That's really nice. Now I have a lovely menu bar where Steve Jobs intended, top of the screen. It hides nicely, not this stupid, in-window thing for you peasants. Yeah, great. And we initialize, we got all this stuff to start up. We got to load maps and textures and airplanes and things. We initialize the GUI fairly on. We show a big splash screen that you just, again, got a thing saying, cool, we're loading assets like any game does, loading textures, blah, blah, blah. And we got crashes in this as well. And it turns out that I hadn't disabled the Mac menu bar during this phase. So people were basically getting so bored, they were going and picking menu items while staring at the splash screen. And of course, they would do something like, turn the weather on and off, or, move the airplane. But of course, the stuff wasn't even ready yet. So then it was like, again, until I went to the thing, added some tracing saying, have we actually done the splash screen yet? No. Well, then maybe we shouldn't be triggering dialogues or whatever. Users are really, really impatient if you don't, well, even if you do tell them how long something's going to take, which you mostly can't do, because if you make a time estimate, it's wrong. If you make a percentage, it's correct, but then it doesn't move reliably. And even then, people still get impatient and just want to start using the software. This one is actually a sort of a QML, I won't quite say bug, but nearly. So we've got some QML UI, and we've got basically this startup thing as a C++ response to it. So that's actually a slot on a Q object, this on launch main thing, that gets called from a QML mouse area on click thing, like a button saying do something. And then, so that could exist, and then basically we show the startup window, which is a QQuick window with some QML GUI, and we say exec on it, and fair enough. And then cool, and then we just do our main startup. And essentially I was getting crashes inside this on launch main thing. And it turns out there's some weird timing around closing the startup window. So that basically calls close on the QQuick window, and then of course the exec bails out. Any guesses here? No, not the context, much worse than that. People hit the button really quickly. They double-click it, or they triple-click it, and if it's dispatched multiple invocations of your clicked, it'll flush them before it closes the window. So essentially, I end up back in this on-launch main thing twice or 3 times, but of course the code there was like, oh, we've already done the setup work, and so something was just wrong in there as well. So now I've got to basically, if we've already clicked the button, don't click it again until we've actually closed the window. And again, each of these, you get the crash and it makes no sense. What you actually have to do is go and add in a bit more tracing information, saying, okay, we opened the dialog, we closed it, we clicked the button to get that kind of trace of what the user was doing, and then you suddenly see in the log, oh, they're closing the button twice, and then it all makes sense. So once you know how it crashes, you go back and look at the early reports and say, oh, I see what it was doing. But getting your brain into that headspace of, because I've never ended up in that code twice, but I don't repeatedly do this on mouse buttons. And it might even be someone with a disability. I mean, some people just double click everything. My dad, because he was taught in 1991, double clicks every single button everywhere all the time, and you can't tell him not to. So yeah, but if someone could easily just be 3 clicks, 4 clicks. And of course, so inside this prepare some stuff, for me it does some file I/O. That probably takes, not even at 1 event cycle, because I've got an SSD. Some guy with a Dell laptop from the dawn of time with a spinning disk, that prepare some stuff might be taking a full second for him that I never even thought about, because again, users' machines are slow. Don't assume your little Q file read of an ini file is quick, because if it's just on the wrong bit of the disk, or they've got some stupid Z drive mapped to an external NAS that spins up because they want to have flight gear on their NAS and not on their C drive, which is fair enough, but then suddenly everything can be slow if it touches a file or other pieces, and then suddenly your timings all go off, and yeah. Oh yeah, malloc. This is actually one that I hadn't really thought about, but really handy. So at least for flight gear, we use exceptions, and therefore we have exceptions enabled in our STL, and therefore we get bad alloc being thrown, which is bad alloc is basically a malloc failure in things like vector or whatever. And we do have some catch blocks in flight gear that basically just show up as a bad alloc, but you've got no idea. It's basically at the event loop level, and you're like, okay, great. Something threw a bad alloc. It turns out there's this set new handler, which is great, because inside set new handler, you're at the control point where the actual allocation failed. And the good thing about things like Sentry and all the other ones is you don't just get to record a crash. You can say, record a backtrace of where I am now in the program, and it'll do it. So it's basically I just put a call to Sentry snapshot backtrace, and that shows up as a non-crash failure. But the good thing is, normally, right after this happens, the program crashed. So now I could do 2 things. I could record where it was, so I have some data coming in on where we have allocation failures. But I could also then show the user, oh, look, you're running out of memory. Because the previous report was, oh, the program just ends. Now I could say, the program's ended because your computer doesn't have enough space for the program, the aircraft you want to fly, or because you want to go to New York, there's way more detail and scenery than there is in Kansas. So you basically have a thing that says, either buy a better machine, or go fly in Kansas, or don't use an Airbus 380, go and use a glider or something, and then it'll hopefully fit in the memory you've actually got. But that's a really good transformation. That's going from a makes no sense crash to an actionable item by the end user in things they know about. So that was actually really nice. Yeah, network can also be slow. Yeah, anything I said about files, also networks, because people have VPNs, and people have ISPs that block some DNS lookups, it turns out. Yeah, so all kind of, so again, I added an updater GUI, just as a very quick HTTP check, just say, look, read a little file, is there a new version out? If there's a new version out, tell the user the usual, there's a new version out, please update. And then obviously that GUI happens, we move on, fine. Turns out some people, the HTTP request just for that one little file takes so long, they'd actually already moved on, closed that screen completely, and then later on we'd get the request timing out from curl, being like, oh, well, it's been 2 minutes. And of course, at that point, The GUI was gone, it had some dangling pointer, and it crashed again. And I mean, I'd never thought that looking up that half kilobyte file would have like a 2-minute timeout, but of course it can in some. And it's not as simple as if you unplug the network cable, it times out immediately with curl. It's something more obscure where it seems like it's working, but takes so long to come back with a failure that, yeah, you've moved on through the whole application flow before even getting the answer back, which, again, it's obvious. I should have done this, but you don't realize. Oh yeah, drivers, actually, I'm not even going to go into drivers because it's just, there's so many ways an OpenGL driver can fail, it's miserable. So the one thing I thought I would do is just check if OpenGL is working. I made a little bit of a, Q OpenGL context, checking if initializers. If Q OpenGL context create returns false, tell the user we bail out. That seemed like easy. Nope. Basically, the Intel drivers would crash doing that, making that first Q context for the window. So I used a Q off-screen window, thinking, okay, well, that's simpler, it's not a Q quick window. And check when it comes back. And that still crashes on some Intel drivers. Even asking, could you maybe possibly think about doing OpenGL, some Intel drivers go, pfft. I don't know why. I've sort of ceased to care, because it's now down from 1,000 people a month to 20, who are all running some unbelievably old Intel driver that just isn't worth thinking about. But it's all horrible. This is one of the things that Qt does to help you with actually a lot, is to try to isolate you from the driver situation. But the minute you do raw OpenGL, you're back to pain there. Right. I just stole this from the Nick Cage movie because it seemed appropriate. There weren't actually that many crashes coming in, comparatively. So I got a bit overconfident. To give another film reference, my overconfidence was my weakness. Yeah, crash report seems manageable. It's a few a day. How about the non-crashing failures? So I put this thing to record the stack trace in our exception handling base class we throw when something bad happens. And we don't use exceptions the wrong way in flight gear. An exception really does mean something bad happened. It's not like end of file. It's like file missing or file corrupt or whatever, or, XML didn't parse. So I put that in. I did a release, and I went to sleep. You can probably tell what's coming now. Yeah, that was a really bad idea. So this is mostly about user-generated content is crap, because whatever percentage of everything is crap. The minute you load anything from a user that you didn't write and then binary sign yourself, it's broken. The XML is broken, the linings are broken, anything from a network will randomly come back as 0 bytes, or, and this is really fun, it'll be a 404 failure web page of HTML content telling you why the file didn't download that looks enough like XML, you start parsing it, and then go, wait, this has got CSS in it, this isn't our data file. Yeah, there's just a whole thing there of anything of a network, if you didn't have a checksum on it, assume it's wrong. You either need to break that up, so I'm going to show a little one of, and then just configuration error. So unfortunately, Flight Gear, being a kind of Linux tool originally, has a GUI, but it also has config files, any files. People will go in there like they do on any game these days, oh, I can enable VR if I go into this .ini file and just change this string to be, some different mode in Unity. It does work. Most people doing this don't know how to edit a config file. They're just going to put in garbage. They're not going to respect quotes or semicolons. They're just going to basically spray out probably RTF into your file and ruin it. Then we also have just OpenGL things like non-supported surface formats, but a lot of them, fortunately, they do crash, so hooray. Yeah, it just goes on and on and on. I'll say I'll do a couple more, but since this is only not a 6-hour talk, and you guys will kill me at some point, I won't just give you the full list, because it gets boring. But if you want to talk about more of these, just come and find me, and I'll just keep going through the appalling horror story of different ways it can go wrong. How long have we got, Jesper? 10 minutes, okay. A few more horror stories. So yeah, most of our aircraft developers do their aircraft content as a zip file. And inside that zip file, there's different bits of textures, XML, whatever, and they all have relative paths to each other. And for very stupid historical reasons, the beginning of those relative paths is the name of the top-level directory. They don't start with a dot like a sane person would do. They start with the top-level folder they expect to be in, which is usually called the name of the aircraft, like Airbus 380 or Boeing 737. And a lot of these projects are on GitHub or GitLab, and there's a feature when you download a branch from GitHub that it makes up a directory name based on the branch and the revision, whatever. And that name is not the name of the project. So we have information in the README and the download page and everywhere else saying, if you download an aircraft from GitHub, you must rename the directory name to be exactly this string here, like Airbus 380, and not develop/Airbus 380 /GitHub/ whatever, or sorry, hyphen. Otherwise, it won't work. Because then you just get file not found in every single file because the relative paths are all wrong. And it turns out that despite all this information, it still happens all the time. So we had hundreds of thousands of file not found errors because one user loading one aircraft will produce 50 reports of the same basic error. So of course now we have some UI that actually checks if the aircraft directory name actually matches what it's meant to be and tells the user, look, you've got to rename this, and just quits the program. But it's that kind of user-facing feedback loops because we can't fix GitHub, and our code isn't wrong, or we certainly can't change it. All we can do is tell the user to really, really do the correction that we told them to do already, which, yeah. Oh, well. SQLite busy one. Oh, yeah, heavens. I'll skip over this one to save time. Oh, this one's good, though. This is another GUI one. So we have a list of add-on directory paths where we're going to search for other locations, a bit like an LD library path, only it's for aircraft and scenery. And it used to just be an environment variable, but I think the users like GUIs. So I added a nice, basically a list view picker of these as an underlying model where there's one entry for each path. So you can go click a plus button and add one, and sure, whatever. And we save this to queue settings, so we've got a list of paths we're going to load. And when we're passing the paths in, we check that they're valid. And when we're loading the paths into the GUI, we check if they're valid, and if they're not, we skip them. And the cumulative result of this is that you end up in your settings file with every single invalid path ever, because people have a USB drive plugged in, and then they unplug it, or they change the drive letter. And because we hide them in the GUI, we don't want to delete them, because the issue is that if the USB drive is unplugged, and they plug it back in, you want to show the path again. So you want to keep it in the GUI, but then, of course, if it's unplugged and we don't show it, there's no way to ever remove it again. So what was happening is when you actually start the real program, you'd get 30 paths being passed in, all of which were C/ZZZZZ or D my USB, and it's just gone, and all file not found, file not found, file not found. And of course, the fix here is the GUI doesn't need to hide the invalid paths. It should show them, but show them with a line through them or grayed out, so the user can see they're there and actually delete them. There's no other option apart from the user to take control in that situation. And I guess a summary of both of these is that writing GUIs is hard because you have to give the users not just enough information, but all the information that they can actually take the actions based on what you're telling them. If you don't give them the information to work with, then it just screws up later on in the program. Okay. Some conclusions here, because I could just go on doing that forever, but it gets boring, and there's actually some interesting things to say here. The thing that really makes this work is seeing it evolve over time. So we got I was doing a kind of monthly release cycle, maybe every few weeks, and eventually knowing when a problem starts is valuable. And then having this context state of correlation is very valuable. So for flight gear, it's we have where you're flying and the aircraft. And if you can see that all the problems happen with one aircraft, you can be pretty sure it's something that aircraft is doing, some feature of the code. If it's a desktop application, if it's some screen that always goes wrong, again, you've got some idea. You also get the update in new versions. That's actually why I added the update thing that then caused another crash, is there's no point fixing bugs and knowing that if you can't eventually see the crash being fixed. So you have to get new versions out there to fix the problem, and hopefully you see your trend line going down because there's fewer users running the version that still have that bug in it. The other thing, again, this gets into analytics pretty quickly, is because it's running and it knows when you start the program, and it also knows when you stop, you get how many sessions fail. And that's been really scary data. So when I first started doing this, I think 1 in 20 flight gear sessions ended abnormally, which is pretty embarrassing. That's, 1 in 20 users don't manage to get through the whole program without it dying on them. It's now up to like one in 50 or it's not quite 1 in 100, because it's not down to 1%, it's down to like 1.5%. But it's quite a good feedback loop as an open source developer to see the software getting more reliable. It also brings me back to when I have my annoying people on mailing list saying the software is getting worse, I can say, no, the software is getting better. It's less crashy than it was 6 months ago or a year ago. You can see the numbers kind of improving. And you could go much wider with this. You could get into performance things like, what's the average frame rate? What's the startup time? But I'm not going there because it's just me. And at that point, you just want to build in Google Analytics and start doing all that kind of work. But the overview of all of this, and I haven't got time now, but if you want to come talk to me, I can show you the data in Sentry kind of running for all this thing, and the historical view and the kind of what's my top pain point? What are the top 10 issues that are causing the most people to have problems in the last 90 days? That's a very actionable thing, and even for a closed source thing, it's very good to go to management and say, look, forget the features. These 5 bugs are affecting this many people today. We should fix those, not add a new feature. The other big thing for me was how well you surface stuff, because we're already good at doing queue warnings and sending things to a log file. And obviously, like we all know, we shouldn't just put up a box saying program failed, quit, which is what FlightGear used to do. And we also all know that you can't show every error to a user, but how you surface errors and how you combine them and where you surface them is like so important for an end user application, because obviously, you've got to get the right level of information, you've got to pick when you do it so it's not annoying. All of those pieces are actually quite hard UI problems, and usually very unconsidered, unthought about UI problems. Again, maybe if you have the data, you can justify saying we need to actually do a better job of handling this class of errors and build an entire dialogue to deal with the consequences and make the program more usable that way. And again, data is best justification there. So for example, this thing of aircraft having corrupt XML files, the old behavior was you hit load, the aircraft loads, but then the seats are missing or the wings are missing because the file was corrupt. And now actually basically go and track in any exception that happens loading an aircraft. I say, okay, this aircraft is a bit broken, pop a dialogue saying, look, it might fly, but it might not fly, and don't bug me, I wrote the software, go and bug the guy who wrote the aircraft, which is a different human being from me, and we can't help you. And that thing of moving the problem around, being like, look, this isn't a FlightGear error, this is an error in the thing you downloaded from this website, go and talk to them. That's already like a massive improvement in the filling up our bug tracker with them saying, oh, the Airbus has no wings. I'm like, yeah, that's because the maintainer's an idiot and can't read XML. But now at least I can tell them, look, it's in that area rather than not. So this kind of categorization and surfacing of problems is a really big deal. Again, user content makes this much worse. If you have a very small lockdown application, it's probably much less bad. A little bit about privacy. You have to be a little bit careful about GPDR here, but again, Sentry is very good about this and does things like stripping usernames from file paths. You do have to do the, on your first run, consent the crash reporter. Just say, we're going to do this reporting, you can opt out. Otherwise, you get into a whole mess. But that's actually very easy. Again, in the case of Sentry, it just helps you do that. So as far as I know, I don't do any GPDR stuff because there is no personal data, and we took care about it. The one interesting one was, because we don't have a username, because an IP address is considered GPDRable, I basically generate a UID on first run and use that to do clustering. Because you do want to know if you've got one report from 100 users or 100 reports from one user. That's a really big information to distinguish if something's worth looking at. So you can do this in a completely, privacy-free way. It doesn't have to be some invasive panopticon of what people are doing with the software. It can be fully anonymous, and it is. Missing features. Oh, yeah, there's one thing people ask about, and I think the one built into Ubuntu does this, where when it crashes, you pop up at the box saying, please tell us what happened. I think Unity does this as well, and basically says, yeah, let the user write in what they were doing and attach that to the crash report. Sentry native can't do that because they would need to go and build in a GUI, and they don't have a GUI. They'd have to build in Qt, which they don't really want to do. I really debate, having seen user-written bug reports, how much use the text box would be for making better crash reports. The more I use the data, like the analytical stuff, the more I like the data, and the less I trust anything the users say at all about what they were actually doing. But conceptually would be nice. And the other one is some of them can capture the last rendered frame, because it's a OpenGL render, and include that in the crash report as a screenshot. And that's also quite a nice idea conceptually for a lot of driver bugs and rendering bugs, except that the minute you're capturing a screenshot of someone's computer, you're into a whole hellish world of what's on their desktop and what. Yeah, so again, I've been a bit like, I'm not going to try and capture the last frame because it also has to allocate memory, which might go wrong, and read OpenGL buffers, which probably won't work. So I'm just kind of doing it'd be really cool to see how it looks when we get this OpenGL shader compile error saying this didn't work, but I just don't think it's worth the trouble. If you're doing something on-premise, it might make complete sense, or your customer base and could consent having a screenshot taken, sure. But for something that's just it's used by kids, it's used by random people on the internet, I don't want to see those screenshots. I think it'd be too weird. So to conclude, as usual, your intuition is wrong about where everything is crashing. Any reporting is better than no reporting. So this is usual, and this is a joke from World War II with the RAF. If you're not sure what to do something and measure it. And that's absolutely the case here. Like, if you're not sure what crashes you've got, at least answer that question, and then you can start doing all these are the top ones. And it has to be iterative. I think that's kind of, most people here now know we're agile, we do fast releases, you put versions out there, you fix the bugs, and you go forth. But it really becomes clear when you're doing this that if you can't get a fix out, there was no benefit. So if you're going to go do this thing of fixing the top 5 bugs, which probably is what you should do, then obviously, hopefully you see those top 5, and along the top 5 you did a new release, and you go again. So none of this would work if we didn't have for Flightgear already, because I built it like a CI and a release cycle and script to push a new version out, so all that thing. If you were doing at least once a year, I can't imagine how you'd make this work. So you've kind of got to already be in that pattern of doing fast development. I think just to end, I will switch to showing what this actually looks like, having talked about it. Here's what you get from Sentry for Flightgear, sorted by, let's go to events, and let's go to what we're on, 90 days. And there's some clustering here, but we can go and see, so the 10th one down is this FDM NAND check fails, and that's affecting 1,000 people in the last 90 days. Okay, that's kind of a big deal. Some of these other ones I'm doing some clustering on now, actually. So these are clustered error categories. We go down, the first actual crash is maybe, there's one. So this is already down to like only 6 people, but they've got 500 crashes in 90 days. That one's something affecting a few people a lot, probably because how that aircraft uses this canvas feature, and so on. But this is kind of the meat of it. If you want to come and talk to me, I can go through the data. But really, it's kind of just seeing these roll in and then picking one, fix one, pick one, fix one. Give it a shot.
That's it?
Mm-hmm.
Thank you very much.
I can still talk. Hooray.
Yeah, amazing. I'm sorry I said this would be a boring talk. You didn't tell me it was about airplanes.
Sorry.
I actually have one question about about Flightgear. You said that, I'm wondering how realistic it is. You said there would be this glider plane over New York. Can you, if you look out the windows, can you see the 2 F-16 intercepting it?
Yeah, sure, especially for you.
So, questions? Yep. Kevin?
So I didn't use Sentry myself. How do you relate tickets inside Sentry to tickets in public tracker, like on
Unfortunately,
GitHub
so Sentry is really, really good about this. They have a whole bunch of APIs and integrations. Can I get the thing back? Sorry. Oh, lovely. So Sentry can do basically smart integrations to other bug trackers automatically. You can smart link your bugs through. It's just that we can't do it because we use this source forge and it's super archaic, and it's a pain. But it's got integrations for, I won't show it now, but you can more or less do linking to bug tracking releases. You can automatically, if you're doing rolling releases, it can work out that a bug probably was caused by a range of commits and say it's probably one of these 4 commits that caused the bug. If you're doing very, very fine-grained, here are the 10 issues fixed, and here are the 20 commits in this release. It'll narrow it down to that. The problem with Flight Gear is most of the bugs are historical, so the first release the bug happened in isn't very useful because it's always version 1. But if you've got a rolling release where you get new features with new bugs that start when that feature goes in, this works super well to narrow down to like nearly a commit, or certainly a cluster of commits, more or less automatically.
Cool. Everybody's just like, wonder what's for lunch today.
Sorry, yeah, we mustn't be late. Sorry, that's important. Like, yeah, we've got 10 minutes.
We got 10 minutes. Any other questions? There's one here.
How well does it work, and if not well, what solutions do you have for platforms which are not usually connected to a network?
So for that particular one, Sentry is useless because it's an online-only one. Crashpad and Breakpad would still work, but then you've got to go and write some code that basically grabs the file they wrote and maybe zips it and then tells the user, put it on an email or a USB drive. Like this kind of offline, can I please dump today's crashes onto some kind of media that can, or now we know we're online for this 1 hour, basically export them. So Sentry itself is an online-only, as far as I know, tool, but there are other ways to make the work which would somehow close the cycle, right? Because the data's still there, it's just getting it. I must say at this point, there's enough feature Sentry gives me in terms of like quality of life, where a different solution would have to give me most of the same ones. But yeah, so the problem I had with doing it, like, there's an argument that if you're in a big organization, I tried this, oh, it's too far back, sorry. Right. So my first try using Crash RPT, if you had a big enough company, you had like a dedicated build guy or a dedicated person to build you a custom backend, you could do much more kind of company-specific solutions using the low-level pieces like Crash RPT and Crashpad and Breakpad. You'd have to probably build your own like backend server that did your own kind of, I mean, all the steps here, the symbolication is just running a command line tool. It's just having a database that correlates, this SHA of this PDB file is this SHA of this installer. It's not a hard job, it's just a lot of boring back-end work to do all that analysis. So if you're a big enough organization, you can do that yourself. But if you're a small person, having someone like Sentry or AppVeyor just do it for you is really powerful. But there's nothing hard in here, it's just a lot of tedious bookkeeping to give you a good interface to the actual data you're producing when you get a crash.
Yeah. Just, yeah.
How does integration of it look into your application, and how does it affect the performance?
It's just a library you link to, and then it's got a C API, you just call it at the right point. Like I could show the code. Flag is open source, I could go and show you, but it's more or less like Sentry, add context key, key value pair, and then you call one init function at the beginning of your program, start up a thread that does the actual monitoring. As far as I can tell, the performance impact is 0 because for it to show up, you'd have to be generating so many reports and errors, like more than 10 a second, that you'd also just fill up your quota, which is like 1 million a month. So if you're doing reporting at any kind of normal, real problem granularity of once per session, or maybe a few errors per session, it's no performance impact that I can tell. Yeah, or certainly it's noise in a working 3D engine.
Yeah. Was that the last question?
I would say come and talk to me afterwards, but obviously I might not talk that much. We'll see how it goes. But I can show the code and dig into the examples quite happily, but obviously not here.
Technically, you said talk to me, not.
Or talk to Jesper.
Well, no, you said talk to me, but that didn't include that you would talk back. So.
Yeah, I'll just listen.
Anyway, thank you very much. Lunch is going to be served next door.